Well, today we're going to look at a third or fourth and final way to solve quadratics. We first of all looked at solving quadratics by graphing to see where they would cross your axes. We then looked at solving them by factoring. We then looked at solving them using completing the square. And by the way, completing the square will always work along with the quadratic formula that we're looking at today. The factoring sometimes only gets you an estimate, and or not the factoring, the graphing sometimes only gets you an estimate, and not everything factors. So the first two methods don't always get you an answer, where the last two methods of completing the square and the quadratic formula will always work. If you have a quadratic equation, and remember a quadratic equation, to solve it using your quadratic formula here would have to be set equal to 0. A is always the number in front of your squared term, B is the number in front of your term to the first power, and C is the one that has no variables. Then you go the opposite of B, plus or minus the square root of B squared minus 4AC all over 2 times A. So let's go ahead and use the quadratic formula on this one here. So the first thing you need to do is make sure it's in the right form. So you need to have it set equal to 0. So you set it equal to 0, so you'd have to subtract the 33. Now, what's in front of your squared term is a. There's nothing written here, so it's assumed to be a 1, because 1 times anything doesn't change it. B is what's in front of your term to the first power. C is the term that's all by itself. So then all we're going to do is take our a, our b, and our c, plugging it into our quadratic formula here. The opposite of your b goes here, plus or minus the square root, and then you put your b squared here, minus 4 times your a, times your c value, all divided by 2 times an a. So then all we have to do is simplify it. The opposite of a negative 8 is 8. On the bottom we still have 2. And then you simplify what's inside your root. And here I would just go ahead and type everything inside the root right into my calculator. It comes up with a number. In this case, that number is a nice number when you take the square root and you get 14. So it's 8 plus or minus 14 over 2. Well, 8 plus or minus 14 over 2, since that's a normal number, you can break it apart into the two possibilities of an 8 plus 14 over 2, and then you get 11. Or your 8 minus your 14 over 2, and then you get negative 3. In this case, we get two different answers, and they happen to be rational numbers, because these could be written as a fraction. So now to use the quadratic formula here, once again, you'd have to set it equal to 0. I like to have it everything on the side where my squared term is positive. So that means I'd have to bring my 34 over by subtracting a 34, x. And then I'd also have to bring over the negative 298, so I'd have to add a 298 to both sides. And so then I get an x squared minus my 34x plus the 298. Now I need to identify my a, b, and c. A is in front of your squared term, b is in front of your term to the first power, and c is the term that has no variables. Then plug it into your quadratic formula. Opposite of your b, which is your 34, square root of your b squared minus your 4 times your a times your c. Go ahead then and type in everything inside your root into your calculator, and you get 0 for this one. And you know the square root of 0 is 0. You also know if you add or subtract 0, it doesn't change it, so it's just 34 over 2, which is just 17. So in this case, we only get one answer, and it happens to be just one rational 0, or one rational root. And that happens when your square root is 0. So we're going to do the same thing here. We're going to go ahead, set it equal to 0, which it already is. Identify your a, which is in front of your squared term, that's 1. B, in this case, your negative 6, and c is your 2. So we plug stuff in once again then and simplify it. We get 28 on the inside of our root. Now 28 is not a perfect square. So that means you need to go and do what we did earlier in simplifying roots. Remember, 28 is a 4 times a 7. So now you'd have your 6 plus or minus. You'd have a 2 in front of your root because the square root of 4 is 2. And then you'd have still that 7 inside your root because you couldn't do anything with it. Now, I notice the 6 is even, what's in front of my root's even, and what's on the bottom is even. So I'm going to write it as 2 separate fractions. Now, in this case, the 6 over the 2 will reduce down to a 3. Still with the plus or minus after it, and the 2 in front of the root drops down to the 2 underneath the root, so it's just plus or minus root 7. So in this case, we have 2 irrational roots. Now, we're not going to break this apart and try to find the 2 different values, because there's nothing we can do to combine our 3 together with our root. So we get 2 irrational roots. And one more here. Your A is your 1, your B is your -4, your C is your 5. Just plug them into the formula. And you get the square root of a -4 inside your, or after the plus or minus. So when you have the square root of a negative, you know you're going to end up with an I. So you're going to have your 4 plus or minus, and you know -4 is really a -1 times a 4. So you're going to have your 4 plus or minus, still all over 2. The square root of that -1 is I. The square root of your 4 is 2. So we get a 2i after our plus or minus. Once again, since everything's even, I'm going to write it as 2 separate fractions. The first one over my denominator and the second one over my denominator. Then I'm going to go ahead and simplify those. 4 over 2 is 2 plus or minus the 2i over 2. And so in this case, I get 2 complex roots. So as a summary here, I had 2 complex roots, 2 irrational roots, 2 rational roots, or at one point I had 1 rational root on the 4 problems we did. So what part of the quadratic formula really determines what kind of a root you're going to get? And while that ends up being what we call the discriminant, because it lets you know the type of answers you're going to have. And that's what's inside of your root. So this b squared minus 4ac is called your discriminant. Now, when we look back at what we did, when our discriminant, what was inside of the root, was greater than 0 and a perfect square, we ended up having 2 rational roots. When the discriminant was greater than 0 but not a perfect square, that's when we had the 2 irrational roots. But when your discriminant was actually equal to 0, that's when we had only 1 rational root. And then, like in the last problem, when our discriminant was negative, meaning less than 0, that's when we got the complex roots. So, what kind of roots are we going to have here? So first of all, you want to find your discriminant, which is the b squared minus 4ac. It does not include the square root. Your b is your 6, your c is your 9, your a is your 1. Plugging it into your discriminant part right here gives us 0. Now, based on the last slide, when your discriminant is 0, which is the third one down, it's 1 rational root. So that's what we're going to put down. Same idea over here. Plug your a, b, and c into your discriminant. Simplify it down. In this case, we get a negative. Remember, when it's a negative inside of your root, that's your complex roots, 2 of them. Same idea here. Plug in your a being 1, your b being 4, your c being -12. And we get 64, which is positive. Question is it a perfect square? Yes, it is, because it's 8 squared. When it's a perfect square, you get 2 rational roots. And then plug in your a, b, and c over here, and then you get 5, which is positive again, but it's not a perfect square, so that means we get 2 irrational roots.